Scientists just realized these animals are smarter than we are. There is a moment that scientists describe, when studying certain animals, that feels less like observation and more like recognition. Not the recognition of something familiar. The recognition of something that recognizes you back. A crow that has never met you before lands on a branch nearby. It tilts its head. It looks at you, not through you, not past you, but at you, with an attention that feels uncomfortably like the attention of a mind. It has assessed you. It has categorized you. And it has decided, based on criteria you cannot fully understand, what you are and what you represent. And then it flies away, and somewhere in the neural architecture of a brain the size of a walnut, it files that information. Your face. Your behavior. The threat level you represent. The potential you offer. And it will remember. Not for hours. Not for days. For years. This is not anthropomorphism. This is not the sentimental projection of human qualities onto non-human animals. This is the conclusion of rigorous scientific research, conducted over decades, by researchers who began their work with every expectation of confirming the comfortable assumption that human intelligence is categorically different from, and superior to, anything else that walks or swims or flies on this planet. What they found instead was something far more interesting. And far more humbling. The study of animal intelligence has a complicated history. For most of the 20th century, the dominant framework in the behavioral sciences was behaviorism. The school of thought associated with psychologists like B.F. Skinner, which held that the proper subject of psychology was observable behavior rather than internal mental states. On this view, talking about animal cognition, about what animals think, feel or understand, was unscientific. You could study what animals did. You could not, with any scientific rigor, study what they experienced. This framework had the virtue of methodological clarity. It also had the consequence of systematically excluding from scientific consideration the very questions that matter most when thinking about animal minds. Do they have experiences? Do they think? Do they understand? The behaviorist consensus began to crack in the 1960s and 1970s, as researchers began designing experiments that could not be explained by simple stimulus-response mechanisms. Animals were making choices that required planning. They were solving problems that required understanding cause and effect. They were doing things that, on any honest assessment, looked like thinking. The floodgates opened slowly. And then all at once. Let us begin with the octopus. The octopus is, by any conventional measure, one of the most improbable candidates for intelligence in the animal kingdom. It is an invertebrate. It has no spine, no bones, no the complex neural architecture that vertebrate animals use for cognition. It is a mollusk, more closely related to a clam or a snail than to any creature that most people would associate with intelligence. Its brain, such as it is distributed throughout its body. 2/3 of its neurons are in its arms rather than its central brain. It lives, in most species, for less than 2 years. It is almost entirely solitary. It has no social group, no family, no community in which to learn from others. By every theory of intelligence that scientists had developed, theories that linked intelligence to social complexity, to long lifespans, to large centralized brains, to vertebrate neural architecture, the octopus should be dumb. It is not dumb. Octopuses have been observed opening child-proof medicine bottles that many humans find challenging. They escape from apparently secure tanks, cross the floor of the laboratory, raid neighboring tanks for food, and return to their own tank before the researchers arrive in the morning. They recognize individual human faces, not just human presence, but specific humans, and respond differently to different people. Some octopuses that have been handled by researchers they find unpleasant have been observed deliberately squirting water at those specific researchers when they walk by. One of the most remarkable demonstrations of octopus cognition involves tool use. In 2009, researchers observed wild octopuses in Indonesia collecting discarded coconut shell halves from the ocean floor, carrying them to a new location, and assembling them into a shelter. This is not just tool use. This is tool collection and transport. The octopus carries the shells before it needs them, apparently anticipating future use. It is planning. The question this raises is profound. If intelligence can emerge in a creature with a distributed nervous system, a 2-year lifespan, and no social learning, if intelligence can evolve independently in a lineage so distant from our own that our last common ancestor was a worm-like creature that lived over 500 million years ago, then intelligence is not the rare, difficult-to-achieve property that we assumed it was. Intelligence, it seems, is what brains do when they have problems to solve. And brains, it turns out, come in many shapes. The crow family, corvids, which includes crows, ravens, jays and magpies, has become the flagship example of non-primate intelligence. The research on corvid cognition has been building for decades, And what it reveals is, by any measure, extraordinary. New Caledonian crows manufacture tools. Not just use tools, manufacture them. They select specific materials, modify them in specific ways, and create implements that they use to extract insects from holes in wood. The tools are not random modifications. They are crafted to specific functional requirements, with hooks at the end that improve extraction efficiency. Different populations of New Caledonian crows have different tool designs, a finding that suggests cultural transmission of technology across generations. Ravens cache food, hide it for later use, and they do so with a sophistication that implies an understanding of other minds. When a raven that has hidden food is observed by another raven, it will often move the cached food to a new location after the observer leaves. But it only does this if the observing raven is in a position to have actually seen the hiding location. If the observer was behind an opaque barrier, the raven does not bother moving the food. The raven is modeling what the other raven knows. It is engaging in what psychologists call theory of mind, the ability to understand that other individuals have their own knowledge, beliefs, and intentions, separate from your own. Theory of mind was, until relatively recently, considered a uniquely human capability. The research on corvids has forced a substantial revision of that view. Western scrub jays, a North American corvid, have been shown to have episodic memory. They remember not just what they cached, but where they cached it and when. They can retrieve the right food from the right location based on how much time has passed, avoiding food that will have spoiled, retrieving fresh food from appropriate caches. They remember specific events from their past, not just general patterns. This is the kind of memory that in humans, we associate with conscious experience, the sense of reliving a past event rather than simply accessing a stored fact. And the crows remember faces. Researchers at the University of Washington conducted a famous series of experiments in which they captured wild crows while wearing specific masks, banded them, and released them. For years afterward, crows in the area would scold and dive-bomb anyone wearing those specific masks, while ignoring people wearing other masks. The crows had transmitted the information about the dangerous mask to their offspring, who had never been captured but had learned from their parents which faces to fear. A grudge. Passed down across generations. Dolphins have long been recognized as intelligent. Their large brains, complex social structures, and playful behavior have made them popular subjects of cognitive research. But the depth of dolphin intelligence continues to surprise even researchers who have spent decades studying it. Dolphins have names. Not names that humans give them, names they give themselves. Individual bottlenose dolphins develop unique signature whistles that function as individual identifiers. Other dolphins use those whistles to address specific individuals, to call them by name. When a dolphin hears its signature whistle played back to it, it responds. It recognizes itself in the sound. This is self-recognition through sound. It is not the same as visual self-recognition, the mirror test that has been used to assess self-awareness in various species, but it may be a form of self-awareness that is more natural to an animal that lives in a world structured primarily by sound. Dolphins use tools. In Shark Bay, Western Australia, a population of bottlenose dolphins has been observed carrying marine sponges on their rostra, their beaks, apparently using them to protect their sensitive skin when foraging along the rough sandy seafloor. This behavior is learned, not instinctive, and it is passed primarily from mothers to daughters, in a pattern of cultural transmission that parallels the way human cultural practices are transmitted across generations. Dolphins engage in what researchers describe as teaching. Adult dolphins have been observed actively modifying their behavior to help younger dolphins learn. Not just allowing calves to observe them, but adjusting their behavior to make the demonstration clearer. This kind of active, intentional teaching, rather than passive observation, was once considered a uniquely human capability. And dolphins play. Not just the simple play of animals in motion, but complex, creative play that appears to have no functional purpose beyond the play itself. They create bubble rings underwater and play with them. They surf waves, not to travel, but apparently for the experience. They engage in elaborate social games with complex rules that vary between groups. Play, it turns out, is one of the most reliable indicators of a complex mind. An animal that plays is an animal that can imagine situations that don't exist yet. That can create rules and follow them. That can pursue experience for its own sake, rather than for any immediate survival benefit. Elephants are the largest land animals on Earth, with the largest brains of any land animal. And the evidence for their cognitive complexity has been accumulating for decades in ways that continue to challenge our assumptions. Elephants recognize themselves in mirrors. This is a significant finding. The mirror test is one of the standard assessments of self-awareness in animals, and most species fail it. Chimpanzees pass. Orangutans pass. Dolphins pass. Elephants pass. The list of species that pass this test is short, and its members are, without exception, species that researchers have also found to be cognitively complex in other ways. Elephants grieve. When a member of their group dies, elephants engage in behaviors that have no functional explanation other than mourning. They return to the bones of deceased group members, sometimes years after the death, and spend time with them, touching them with their trunks, standing quietly near them. They respond differently to the bones of elephants they knew than to the bones of elephants they didn't, suggesting that the mourning is not generic but specific, directed at the individuals they have lost. Elephants cooperate to solve problems that require coordinated action. In experiments where food can only be obtained by two elephants pulling opposite ends of a rope simultaneously, elephants learn the coordination task, and crucially, they wait for their partner before beginning to pull, even if it means waiting for a partner who is distracted and must be alerted. They understand that the task requires cooperation. Elephants have been observed helping other elephants in distress, removing snares, helping calves out of water holes, supporting injured group members. This helping behavior is not limited to close relatives. It extends to less related individuals within the group, and in some cases to members of other groups. And elephants learn from each other in ways that accumulate across generations. Different elephant populations have different knowledge bases, knowledge about migration routes, water sources, food availability in times of drought, that is transmitted from older to younger animals. An elephant herd that loses its oldest members loses not just individuals but knowledge, irreplaceable information about how to survive in their specific environment. The great apes, chimpanzees, bonobos, gorillas, and orangutans, are our closest relatives, and the evidence for their cognitive complexity is extensive enough to fill libraries. But the most recent, and in some ways the most provocative, findings concern not what apes can learn but what they understand about themselves and others. Chimpanzees have been shown to have a sophisticated understanding of social hierarchies, alliances, and reputations. They track who is allied with whom, who owes whom a favor, who has recently gained or lost status. They engage in what can only be described as politics, forming coalitions, making and breaking alliances, managing their social relationships with a sophistication that would be recognizable in any human organization. They also deceive. Chimpanzees in competitive situations will conceal information, mislead competitors about the location of food, and engage in calculated deception in ways that demonstrate an understanding of other individuals' mental states. You cannot deceive effectively without understanding that the deceived individual has beliefs that are different from yours, and that can be manipulated. Bonobos, the less well-known of the two chimpanzee species, have been shown to engage in food sharing with strangers, a behavior that is rare in the animal kingdom and that in humans is associated with complex prosocial motivations. They share not because they are required to, not because the sharer gains an immediate benefit, but apparently because sharing is valued in itself. Orangutans, the great apes of Southeast Asia, more solitary than chimpanzees and bonobos, have been shown to plan for the future in ways that go beyond what was previously believed possible in non-human animals. In one study, orangutans were shown a tool that would be needed to access food in the future, and they carried the tool with them to the future location, up to 14 hours later, to use when needed. They planned. They acted on that plan across a significant time delay. What does all of this mean? It means that the assumption of human cognitive uniqueness, the belief that intelligence, self-awareness, planning, emotion, culture, and communication are uniquely human properties, is not supported by the evidence. It means that many of the capacities that we have used to define the human, to separate ourselves from the rest of the animal kingdom, to justify the ways in which we treat other species, turn out to be present, in various forms and degrees, in other animals. This has implications that go beyond biology. If elephants grieve, what does it mean to kill them for their ivory? If dolphins have names and teach their children, what does it mean to hold them in captivity for entertainment? If octopuses plan and recognize faces and bear grudges, what does it mean to boil them alive in restaurant kitchens? If crows pass down memories of individual humans to their offspring, what does it mean to destroy the habitats where they live? These are not comfortable questions. They are not questions that have easy answers. The relationship between humans and other animals, as food sources, as entertainment, as research subjects, as competitors for habitat, is too complex and too deeply embedded in human culture and economic life to be transformed overnight by a change in our understanding of animal cognition. But understanding matters. The history of moral progress is, in large part, the history of expanding the circle of beings whose interests we consider worth taking seriously. Every expansion of that circle, the abolition of slavery, the extension of rights to women, the recognition of the rights of children, was preceded by a shift in the way those beings were understood. A recognition that they were more than they had been assumed to be. The science of animal cognition is producing exactly that kind of shift. It is showing us, with increasing clarity, that the minds of other animals are more complex, more rich, and more like our own than we have been comfortable admitting. There is a crow somewhere that remembers a face. Not your face, probably, but someone's face. A face that belongs to a person who years ago did something that the crow registered as significant, a threat, a kindness, an unusual behavior, and filed away in a brain the size of a walnut, in a memory that has outlasted seasons and territories and the deaths of other crows who witnessed the same event. That crow is, in a very real sense, thinking about a human being. Which raises a question that is easy to dismiss and impossible, once you have truly considered it, to forget. Has the human being ever thought about the crow?